This next video is going to be graphing functions defined piecewise. So in that last section, we were giving you these piecewise functions. Okay, so it's these graphs made up of these different pieces to come up with one big function. And now we are just going to come up with these pictures. So they are going to give us equations to define each piece, and they're also going to restrict our domain so that we end up with a functional graph. So for example, if you look at this piecewise function, the first piece is that y equals 4, so you get a constant function for any x value less than or equal to 0. So that what that means is that from here down, it's going to be defined by a constant function. Then from 0 to 2, so this time they actually use square and round versus not, right? So from 0 to 2, so round bracket at 0, because we already had a square there, up to the 2 with a square bracket, we are going to define this piece by a quadratic function. So I'm going to expect this curve shape. And then the last part is going to be for my x values of 2 to infinity. So again, I'm switching from a square to a round because they're going to share that x value. And from 2 to infinity, I would be defined by this linear function. So the first thing we're going to practice is just plugging numbers into the appropriate equation. So if I ask you for the piecewise function below, find the specified function values. So I want you to find the y value when x is -3. So the first thing you have to do is figure out which domain -3 is in. Is it in less than or equal to 0, 0 to 2, or 2 to infinity? Well, it's in less than 0. So when I'm putting in an x value of -3, I'm putting it into this restricted domain, which is this expression 4. So no matter what the x value is, y is 4. If I now want you to put in an x value like 1, 1 is in this restricted domain. So I'm going to be plugging into 4 minus x squared, and in for the x, I'm going to put a 1. So for this one, I'd get 4 minus 1, which is 3. So when x is 1, I get a y value of 3 on my functional graph. The next one I want to put in is x is 2. Now I chose this one because of this. This function is for x values that are greater than 0 and less than or equal to 2, whereas this expression defines the y values when x values are greater than 2, but not equal to. So we are going to plug into this second function again. So we're going to plug into 4 minus x squared, where we're going to put in x is 2, and I get 4 minus 4, which is 0. And then the last one is an x value of 4, which is greater than 2. So I'm going to plug into this linear function, 2 times 4 minus 6, which gives me 8 minus 6, which is 2. So that's what we're doing. We're going to be making tables of values and figuring out which x values we should plug into each expression depending upon the restricted domain. And if you wanted to check, it's kind of nice to look back here. When x is -3, y is 4. Yep, there's that point. When x is 1, y we said is 3. Yep, there's that point. When x is 2, let me just scroll down a little bit. When x is 2, we said that y is 0. Yep. And when x is 4, we said that y is 2. So all of these points that we found are on this graph that was done for you. Now we're going to graph from scratch. So my biggest hint to you is however many expressions you have, so however many different pieces you're graphing, draw that many tables of values. So a table of values is an x and y table. This one is going to be that y equals x squared. And you're going to do this for all the x values less than 0. So even though it's not going to include 0, I always start at 0, and then I pick values of x that are less than 0 that go nicely into whatever the function is. So since this one is an x squared, I can choose whatever I want. So I'm going to pick -1, -2, -3. That'll be tons. And then I just solve for y. But before we do that, let's actually draw our other one. So there's 2 pieces. Let's draw our other table of values. This one is going to be y is equal to x plus 1, and this is for all x values greater than or equal to 0. So I'm going to pick 0, 1, 2, 3. Now, before I go on, I have to be really clear that in this graph, its x is less than 0. And in this graph, I'm picking x is greater than or equal to 0. Somehow I have to show that this one is a closed circle and this one's going to be an open circle. So I always circle any x values that I chose in my table of values that are not equal to. So again, I always pick them, but I always make sure I circle them so that in my graph I do it as an open circle. All right, now let's find the y values. So for these ones, we're plugging it into y equals x squared. So 0 squared is 0, negative 1 squared is 1, 2 squared is 4, negative 3 squared is 9. So I'm going to plug this first point at 0, 0 as an open circle, and then at negative 1, 1, negative 2, 4, and negative 3, 9 doesn't fit. And maybe I should put that in. 0 squared, negative 1 squared, in case you're looking back at this and going, what did she do? All right, and then this one I'm plugging in my values 0, 1, 2, 3 into this expression. So it's going to be 0 plus 1, 1 plus 1, 2 plus 1, and 3 plus 1. So that that is not a 1, plus 1. So that my y values will be 1, 2, 3, and 4. So when x is 0, y is 1. This is a closed circle above an open circle, so it maintains being a function. When x is 1, y is 2. When x is 2, y is 3. When x is 3, y is 4. And again, I don't have a ruler, so I'm just going to keep putting points, and then I'm going to connect them. And that's my piecewise function. So I have a quadratic function as expecting a parabolic shape, and then I have a linear function as expecting a line, and the quadratic function was for x values less than 0, and the linear function was for x values greater than or equal to 0. All right, I have two more, so let's do one more together. So this time I have 1, 2, 3 pieces, so I'm going to draw 3 tables of values. I'm going to do them right off the bat here. This is going to be x where y equals 4. This is going to be x where y equals x plus 1. And this is going to be x where y is equal to negative x. Now for this first one, I'm going to pick values that are less than or equal to 2. Less than or equal to 2. So I'm going to pick 2, 1, 0, I don't know, maybe negative 1. For this next one, I'm picking values that are greater than 2 but less than 4. So again, I'm going to pick 2, and I'm going to pick 3, and I'm going to pick 4, but they're not equal to 2 and 4. So I'm going to circle the 2 and the 4. And then my last section is going to be for x values that are greater than or equal to 4. So I'm going to pick things like 4, 5, and 6, right? And I don't need any open circles. Now let's do it. So for this first one, it's a constant function, so it doesn't matter what x is. Y is just 4 all the way along. So I'm going to put a closed circle at 2, 4, 1, 4, 0, 4, and so on. I'm going to try my best to draw a straight line. For my next little piece, I'm picking the values 2, 3, and 4. So if I plug them into here, I have 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. That 4 came out a little funky. So when x is 2, y is 3, but with an open circle. When x is 3, y is 4. When x is 4, y is 5 with another open circle, because again, there'll be a point on the same vertical line as that. And then my last one is that y equals negative x, so negative 4, negative 5, and negative 6. So starting at 4, negative 4 with a closed circle, 5, negative 5, 6, negative 6, and so on. And then I'm going to connect those dots and draw an arrow to show that it keeps going. And that's my piecewise function. So what I'd like you to do is pause the video and give this one a go. So again, 3 pieces. First decision is what to choose for x. I'm going to draw 3 tables of values. My first one's going to be for x values that are less than or equal to 0. This one will be greater than 0 but less than or equal to 3, and then this one is greater than 3. So for this one I'm going to pick 0. Now for this one, when I look at it, I always pick y values that or x values that are going to make my equation nice. So y is equal to negative 1/3 x plus 2. Because I have to take a third of my x values, I'm going to pick x values that are less than 0 but are also divisible by 3. So I'm going to pick negative 3 and negative 6, and that's all that'll fit on my grid. For this one, I'm going to pick x values between 0 and 3. So this is y is equal to x minus 5. There's nothing I can't subtract 5 from. So I'm going to pick 0, 1, 2, 3. So when it's a sandwich like that, I always pick all the values between there. And then the last one is y is equal to negative 2x plus 2. And I'm going to pick values that are greater than 3. So 3, no division, so 3, 4, 5 will be good. So now we're going to plug those in and solve for y. Before we do that, don't forget your open circles. Anything I'm not including. So for this one, I'm not including the 0. For this one, I'm not including the 3. All right, now let's complete our table of values. This one is that y is going to equal negative 1/3 times 0 plus 2, which is 2. This one is going to be negative 1/3 times negative 3 plus 2. So negative 1/3 times negative 3 is positive 1, plus 2 is 3. And then the last one here, y equals negative 1/3 times negative 6 plus 2. Negative 1/3 times 6 is the same as negative 6 divided by negative 3, which is 2, plus 2 is 4. So I'm going to graph those. So at 0, we have a point at 2. At negative 3, we have a point at 3. And at negative 6, we have a point at 4. And I can connect those right away. Now, if you're someone who knows a lot about graphing and you're super comfortable with the fact that this is a linear graph with a y-intercept of 2 and a slope of negative 1/3, that's great, right? You don't necessarily need your table of values. The next point is going to be y values where you take x and you minus 5. So it's going to be negative 5. 1 minus 5 is negative 4. 2 minus 5 is negative 3. And 3 minus 5 is negative 2. So I'm going to have a point at 0, negative 5 with an open circle. I'm going to have a point at 1, negative 4, 2, negative 3, and 3, negative 2. And I'm just going to connect those dots. And then my last section is going to be negative 2 times x plus 2. So negative 6 plus 2 is negative 4. Negative 2 times 4 plus 2, which is negative 6. And negative 2 times 5 plus 2, which is negative 8. So to graph these, I have a point at 3, negative 4, 1, 2, 3, 4, with an open circle so that it maintains being a function. I have a point at 4, negative 6, and I have a point at 5, negative 8. And again, it keeps going, so I'm going to put an arrow at the end. Whew, that's a fun one. So that one was made up of 3 linear functions. They don't do quadratics. Well, they don't do anything beyond. Like they don't really do square roots or cubed roots, or definitely don't do reciprocals or anything for any of these sections, but you could do them just the same. So pick x values in the domain that they're giving you. If there's anything that's like a sandwich, pick all the numbers between that sandwich just so that you get all the points, unless you're super confident with graphing your shapes. And then you should be fine with piecewise functions.